Welcome back, focused learners, to another explainer. You know, if you've ever stared at a beautifully crafted data chart, maybe one tracking explosive product growth, user retention, or feature engagement, and wondered, how exactly was that put together? Well, you're in exactly the right place. Today, we are taking on the goal of truly mastering data visualization. But, and this is key, we aren't going to do it by just memorizing a bunch of rigid, pre-packaged templates. Instead, we're going to learn its underlying language. We're going to learn the structural grammar that makes absolutely any visualization possible. We'll be going step by step through the ggplot2 grammar, breaking down how to build visualizations layer by layer so you can uncover the deep logic behind your data and your product's growth.
Okay, let's dive right into this with a core philosophy that is going to completely shift how you think about creating charts. Every ggplot is built, not drawn. I really want you to internalize that concept. When you try to just draw a chart, you're usually locked into whatever a specific software menu decides to offer you, right? Like a basic pie chart or a standard bar graph. It's super rigid. But when you switch your mindset to building, you realize that data visualization is actually a constructive process. It's basically like architecture. You're assembling distinct, logical pieces to create exactly what you need to analyze all the complexities of a growing business.
And this brilliantly illustrates our master blueprint. This is the complete architecture of the ggplot2 grammar pipeline. As you can see, on the left side, you start with your raw data, and as you move across to the right, you're passing that data through distinct phases, mapping, geometry, facets, until it emerges on the far right as a totally polished, completed visualization. A finished chart isn't just some single magical image that appears out of thin air. It's a stack of these distinct, logical components, all working together in perfect harmony.
So, here is our game plan for today. First, built, not drawn. Second, step 1, data foundation. Third, step 2, visual geometry. Fourth, step 3, faceting subsets. And finally, we'll wrap up with section 5, the finishing touches.
Let's kick things off with section 1, built, not drawn.
The absolute secret to the grammar of graphics is composing layers rather than issuing standard drawing commands. Every single plot is constructed by stacking these specific layers right on top of one another. So why does this matter to us? Well, because it gives you, the creator, ultimate freedom. Instead of relying on a limited, boring library of pre-drawn charts, you can mix and match layers to custom build a visualization that perfectly fits your unique data. Think about it. When you're trying to figure out the exact logic behind why a specific feature drove product growth last quarter, a standard out-of-the-box pie chart just won't cut it. You need a custom build to tell that specific story.
And these are the 5 core layers that make up our project blueprint for that structural build. You always start with 1, data. Then you move into 2, mapping. Next, you define your third layer, geometry. You optionally slice it all up with 4, facets. And finally, you render the whole thing with 5, visualization. We're going to walk through these sequentially right now so you can see exactly how this constructive process happens in real time.
Moving on to section 2, step 1, data foundation.
Before you can build a house, you got to have raw materials, right? Our very first layer simply supplies the raw observations that you actually want to visualize. In the grammar, this is controlled by the data equals component. It's the absolute bedrock of the entire visualization pipeline. Without data, there is literally nothing to map, nothing to shape, and nothing to see. You're just pointing the system to the exact data set you want it to look at, whether that's user signups, retention metrics, daily active users, or revenue growth.
Let's actually look at what that means in practice. We have 3 columns here, an X value, a Y value, and a group labeled A or B. Imagine for a second that X is days since launch, Y is active users, and the groups represent an A/B test of a highly anticipated new product feature. Right now, these are just abstract concepts on a screen. They have no physical form, no shape, no color. To make them visible to us, they need a physical representation, which requires us to step right into the very next structural layer.
And this is the absolutely crucial step of mapping, which in the code is often referred to as S, short for aesthetics. Mapping connects your raw variables to visual aesthetics. So you're taking that abstract X column, our days since launch, and telling the system to map it to the horizontal axis. You map the Y column, our active users, to the vertical axis. And you might even map that group column to dictate the color. So maybe your feature A users are colored blue and your feature B users are colored red. You are establishing the fundamental rules of translation between raw business data and physical appearance.
Which brings us to section 3, step 2, visual geometry.
Now, mapping still isn't quite enough to show us a chart. It just sets the rules. So the crucial point here is the geometry actually determines how those observations are displayed. You've provided the data, you've mapped the variables to the rules, now geometry is the physical ink on the page. Do you want those data points to be little dots? Do you want them connected by a line to clearly show the growth momentum of that A/B test over time? Or maybe you want them represented as solid bars to emphasize the total user volume for the month. To actually do this, you use specific geometry components. And honestly, the absolute beauty of this layer system is that you can keep your exact same data foundation and your exact same mapping rules and simply swap out the geometry. Use geom_point, and boom, you instantly have a scatter plot. Swap it for geom_line, and you've got a line chart showing trends. Swap it for geom_bar, and you have a bar chart for hard comparisons. It's modular, it's incredibly fast, and it gives you total flexibility, letting you rapidly iterate to find the exact visualization that best highlights the logic behind your product's growth.
Next up, Section 4, Step 3, Faceting Subsets. So what if your business data is super complex and simply mapping colors or shapes just isn't quite enough to make sense of it all? Well, faceting allows you to take your plot and repeat it across different subsets of your data. The code component for this is often facet wrap. Instead of cramming all your groups onto one single incredibly messy chart, faceting breaks them apart. It creates what data designers like to call small multiples. So, if you have groups A, B, and C in your data, say free, basic, and premium subscription tiers, Facet Wrap will instantly generate 3 separate, perfectly aligned mini charts right side by side. This makes it insanely easy to compare growth trends across your different user segments without any of that visual clutter. Which naturally leads us to Layer 5, Visualization. Now, this isn't so much a specific line of code as it is the final core layer of the process. It's the ultimate output where the system actually renders everything we've just built. The data has been mapped, the geometry has been applied, the facets have been arranged, and now the final plot is fully displayed for real-world insight and storytelling.
Finally, Section 5, the finishing touches.
But you know, a house isn't really a home until you paint the walls and hang the signs, right? We need to polish our build using what's called the extended grammar. First up is the theme function. The theme component essentially acts as the interior design of our build. It controls all the non-data ink. This means you can adjust the visibility or style of your grid lines, change the background color from gray to white, update the typography and fonts to match your company's official style guide, and even perfectly position the legend. It's all about making the plot visually appealing and incredibly professional for your stakeholders without changing that underlying data structure at all.
Now, what's really interesting about this step is the labs function. Labs is just short for labels, and it's what makes your plot truly interpretable for your audience. Because a chart without context, it's just abstract shapes. The labs component gives your plot its storytelling voice. You use it to clearly assign a title, give context with a subtitle, add a caption to cite your sources, and clearly define your axis labels so the viewer knows exactly what they're looking at, like titling it Q3 Premium User Retention, instead of just leaving everyone guessing. Let's bring back that master blueprint one last time to truly appreciate this whole journey. We started on the far left with just raw rows and columns of numbers. We systematically moved to the right. We mapped those business variables to visual rules. We chose a specific geometry to represent them physically. We learned we could facet them into small multiples to analyze different product segments. And finally, we ended on the far right with a beautifully rendered visualization, perfectly polished with our extended grammar of themes and labels. The transformation is entirely logical, step by step.
And that brings us to the end of our explainer. You now understand that charts are not just drawn, they are constructed layer by layer with incredible precision and logic. You literally have the architectural tools and the grammar to create absolutely any visualization you can imagine, unlocking the deep logic behind your data and driving your product's growth. So I guess the only real question left to ask is this. You know the grammar. What will you build?